draw a picture. Now at this point we understand how useful a picture is, so we're going to draw a jumbo-sized picture because now we can just work on the triangle inside of it now that we see how this thing works. So 17 would be out here, negative 19 would be down here. So this is a distance of 19. It is negative 19 as a coordinate, but we can also just treat it as being a distance of 19. Here is a distance of 17. Our r is going to be this side of the triangle. Remember, it's a right triangle. And we know that not theta. Theta is not inside of the triangle. Theta was the counterclockwise spin like this. This is our theta. What we've got inside of the triangle is some other angle. I'm deciding to call it alpha. You could call it smiley face. You could call it any symbol you want to use. Alpha is an easy one for me to draw. So I'm calling it alpha inside of the triangle. So we can figure out r pretty easily. It's just a right triangle. We can figure out alpha pretty easily. Basic trig function, tan theta. And then we can use theta and alpha's interaction together to figure out what theta has to be. So first off the bat, let's figure out what is our r. So r, we can see that we've got r here. The hypotenuse squared is equal to the other two legs squared, so 17 squared plus 19 squared. We work that out, so we've got r squared is equal to, I'll take the square root of both sides, and eventually we work this all out, 17 squared plus 19 squared, and it simplifies to r equals 5 root 26. And you could probably get away with putting that in a decimal form if you wanted, but exactly what it is r equals 5 root 26. Next up, let's figure out what alpha has got to be. Well, since alpha's in here, we see that tan alpha is equal to, who is the opposite? The opposite from that angle is 19. So 19 divided by the adjacent to that angle is 17. So divided by 17. We take the arctan of both sides. Alpha is equal to the arctan of 19 over 17. Now, that doesn't come out to be any friendly, nice form. That's not a really nice number to have to deal with. But if we punch it into a calculator, it'll wind up coming out as to be approximately 0.84. If we wanted to have it absolutely perfectly, we would have to leave it as tan inverse of 19 over 17. But we can probably have a decimal approximation, so alpha is approximately equal to 0.84. We'll probably do for our purposes of answering this question. Now, how do we get to the actual answer? Well, we have to figure out, how does theta and alpha relate? Well, if we did a spin here, we could do one entire revolution. One entire revolution would be 2 pi. So we see that theta combined with alpha, right? If we spin most of the way and then we have the angle that we do in the triangle, well, that comes out to be one entire revolution. One entire revolution is 2 pi. So that means that theta plus alpha in this case comes out to be 2 pi. As we saw in the previous one, it came out to be pi. So we really have to pay attention to the picture we're looking at. There's not just a simple formula here. It's think and use pictures. Pictures and thinking. Without thinking, nothing will wind up working. Theta plus alpha equals 2 pi. What's our alpha? We have our alpha is 0.84. So theta plus 0.84 equals 2 pi. Actually, let's write it a little bit differently. I'd prefer to write it as theta equals 2 pi minus alpha, then we'll substitute in. So we have theta equals 2 pi minus 0.84, which gives us theta is approximately equal to, plug in 2 pi, 2 times 3.14 minus 0.84. We get approximately 5.44 for our value here. So that means we could plot the point as being 5 root 26, right? Our r value over here of 5 root 26 and comma 5.44. Oh, sorry. Theta comes out to be 5.44. So 5.44. That's what we wind up figuring out as our approximate value. If we wanted it precisely, we could leave it as 2 pi minus tan inverse of 19 over 17, but we'll probably wind up being okay with just having this approximate value right here of 5.44. Now, we didn't do this in the last problem, but I want you to see that you can also check your work here. If you're not quite sure that it all came out right, we can check our work. We can go to polar, but then since it's so easy to convert from polar back to rectangular, we just plug them in. Remember, to convert to rectangular, x equals r cosine theta, y equals r sine theta. So I will put in the middle this sort of checking box. So if we want to do a check, well, x equals r cosine theta, so that means x is equal to, what's our r? Our r is 5 root 26, so 5 root 26 times cosine of 5.44. We plug that into a calculator and we wind up getting x is equal to 16.96. What did we have originally? We originally had 17, and remember we wound up having some round off error because we had to round because it was tan inverse of 19 over 17, so we rounded to 0.84. So that makes sense that we're winding up seeing 16.96 compared to 17. It's just round off error, but basically our answer is correct, so it checks out. Same thing for y. Y is equal to r times sine theta. Our r here is 5 root 26, and our sine is 5.44. We plug that into a calculator and we wind up getting negative 19.04. Compare that once again to negative 19. The only thing we're seeing here is a slight bit of round off error, so this checks out because we knew that we'd have some rounding off error because we had rounded it as opposed to using what it was precisely. So if you're ever in a situation where it really, really matters that you wind up getting this right, like you're on a test or you're confused about how this stuff is working out, just wind up checking it. Once it's so easy to convert from polar to rectangular, the hard part's converting from rectangular to polar. So if you're in polar, you might as well convert back to rectangular at the end and check and make sure that you got the answer right, especially if it really winds up mattering, like in a situation where you're taking a test or an exam of some sort. All right, so now that we've got a good understanding of how polar coordinates work, we're ready to talk about polar equations and functions, really get into the meat of graphing this stuff. All right, we'll see you at Educator.com later. Bye.